We will now come to the simple algorithm, and it makes use of the following equation, namely that the set of dominators of W is W itself plus the intersection of dom for each P of W, for each predecessor of W. Which means, in other words, that nodes which dominate all predecessors of W should be in W plus W itself. Okay? We cannot compute this directly because due to loops in the code, we need to iterate this. So we will start with an overestimation and then remove vertices from the DOM set of a vertex. I mean, we remove those which do not dominate the node. This might look confusing at first, but with an example, it will become obvious. Okay, so this is a way to compute DOM for each vertex. And we start with, for the start vertex, that this is the correct result. It's only dominated by itself. And then we overestimate for all other vertices and say that every vertex dominates W. Then we iterate until there is no change. So we set change to true and start. Okay, so then we go through each vertex except the start vertex. We take the old value of DOM W, which we will use to see if there was a change. Okay, then we compute DOM W as well, like this. W in a set union the intersection of DOM P, where P is a predecessor of W. Okay, and if there was a change, then we need to iterate through again. That means we go through all vertices again. Okay, I can just mention that it is possible to improve this a bit by not going through all vertices again, but instead using a work list of those which need to be recomputed. But that's a different issue, since we will not use this algorithm anyway. But this is an example of iterative data flow analysis, and then it's better to use a work list when we need that. Okay, so let's see an example. Here we have a funny graph, which is exposing a goto into, so this vertex 2 could be a if statement, and one of them is the then and the other is the else, and then we have a conditional branch into the to one of the parts. So it's not so in beautiful code, perhaps. So we see this, and we start with initializing all the data structures. That means here. So vertex 0 has itself as the set of dominators, and the others have all vertices. Now we iterate this, and vertex 0 is unchanged. For vertex 1, it is, well, we compute it and we take the intersection of the predecessors, which is only 1, so it will become this. And 2, it will get the 2 and these 2. 3, it will get 3 itself, and then the intersection of the dominant sets of each predecessor. And the predecessors are 1 and 2. And then we look here and we see that the intersection is 0, 1, and 3. 0, 1, and 3. Okay, and now we continue like this and take the intersection of the dominance sets of each predecessor. So this is the first iteration. And then there was a change, so we must do another iteration. But what is interesting, we can see here that 5 has 4 as a dominator. That's not correct. What is the correct value of DOM 5? Well, it's none of these, since I mean, it should be 0, 1, and 5. Not 2, because we can skip 2 and go like this. And not this either, of course. Okay, but we start with overestimating, and then we remove those which should not be there. So in the next iteration, we see that 5 is changed, and it has now well, it's the intersection of this. So what is that? It's 0, 1, and 3, 4 are removed since they are not present there, and 6, 7 are also removed. So it's 0, 1, and 5 after the second iteration. And after the third iteration, which the algorithm does because it doesn't know that it will remain the same, then it will also be the same, and the algorithm terminates. So this is the result.